Let's make the assembly of wobbler steam engine. We did all the parts. Now start to assemble. Now you will see this assembly 1 to 8 part, and you will see in column all parts are in one quantity and material also shown, and the unit shown here in inches. So let's start to create this assembly. Now go to file and open new, and here choose assembly, say OK. Once you open, it will automatically start begin assembly, and this window pop up open. So first part by default fixed, so I am going to choose column, open. Now before going to place somewhere, I am going to open this visibility on off, and here choose open view origin. And if I move my cursor over origin, it is going to fix. See, click on this origin and the part is fixed. It will show you some warning, but let's forget. Now you can't move this component. Right click, float. It means this is fixed. By default this is fixed. Now I don't need this, so you can turn off view origin. Now insert, before going to insert, let me change unit IPS. Insert component. Now the second component bearing, open. Now place somewhere here and drop down and choose rotate component, and rotate this head here because this head I want to be here. Say OK. Now activate MET. Here selected, we are in standard MET operation, MET selection. Let me choose this whole of the column and this face, and it will show you a relation, concentric relation between these two. Say OK. Now I am going to select this face and select this face, and here again a relation created, coincident relation between these two. Okay, now I want to fix this because this is rotating, so I want to do one more relation. Front plane of column and front plane of bearing. If I select this, see, it will rotate. Look how it is rotate, and this is in one plane. Coincident relation, say OK. Cancel. Now let me save this as a wobbler steam engine assembly. Save. Now let's correct this. Insert component. Now next component, let me select cylinder, open. Now move somewhere here and place, activate MET, and let's create a relation between cylinder and column. So I am going to select this internal surface of this hole and outer surface of this and make relation concentric relation. Okay. Now see, this is going to rotate along with this. Now I am going to select this face and this face. Coincident relation. Fine. Okay. Now I'll keep this one as it is, and I'm going to bring some other part. Insert component. This time let me hold Control key and select these two parts, piston and crankshaft. Now place piston here and the crankshaft here. MET. Now let me little rotate. Okay. Now select internal face of this piston, cylinder and piston. Concentric relation. Okay. Now let me fix. Select this rod and this hole face. Now I want this web this side, so here you have option flip MET alignment. Even this option you will also here MET alignment, rotate. See. Okay. Now bring this here. Now important relation, select this face and bearing face, and a coincident relation going to be created between these two. Okay. Let me rotate. Okay, let's select the whole of this piston and this face, concentric relation. Okay, now let me rotate this component and we will get idea how it going to work. See, okay, let's insert the next component, flywheel. Okay, let me insert here, rotate component. Okay, met. Now I am going to select this internal hole and crankshaft rod, concentric relation. Okay, now the face of bearing and the face of flywheel, coincident relation. Fine. Now here I am going to create a relation between crankshaft and flywheel. So let's activate crankshaft. Right plane of crankshaft, come down, choose from here flywheel, right plane of flywheel. Look how it is changed. Coincident relation, say okay, cancel. Now, if I am going to rotate this, see the flywheel also going to rotate. Okay, let's insert last two components. Washer, control key, nut. Open, place somewhere here. Rotate component, take it in vertical position. Okay, met. Let me select the hole of nut and face of cylinder rod, concentric relation. Okay, now rotate this little inside and let me choose these two face, and here you will see a distance, apply distance. You will see here 0.02 inch. Enter and you will see rotate and see the preview. Okay, that's it. Now I want to fix with okay, let me select this hole and this one, concentric relation, coincident relation actually. Take back, select this face and this face. Okay, see, now you will see this is steam exhaust inlet, exhaust port. Clear. Now I want to fix this. So I want to fix with this column. So if I am going to select front plane of column, come down, nut, right plane of nut. You will see it is rotate and it's going to fix in one plane. Say okay, coincident relation. Now look. Now let me save this, rebuild and save. Right click on command manager and go to toolbar and here activate motion manager. Now activate motion study. Now here I want to give some little more motion, so I'll go for animation. Open, frame unit, animation frame unit. 60 frame will give more smooth, but it will utilize your system very powerfully. It will take too much course, so just check is it capable your computer or not. Say okay, and I'm going to directly apply motor, and I'm going to apply motor on this face. Motor type rotary, component directly we selected here, reverse direction. See, and here let's say 30 frame per RPM. Okay, now just calculate. Now see, this is calculating Once calculation finish, now you can play. Drop down. See, even if you want to go back, play, look, reverse and forward, stop. And let me save this animation. Here give the name, video type MP4. Okay, keep this render. Now image size or video aspect ratio, you can change custom aspect ratio from here 16:9. You will see the window, preview window. And here frame, this is important, either 50 or 60. For smooth animation I'm going to keep 50, 60. Save. Now once you save, it will recalculate from start and it will save in your destination. So don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. I hope you learned basic features of SolidWorks assembly. Thanks for watching.